Okay, now let's work problem 2 on page 21 of the student packet. This graph is a velocity versus time graph. It's not telling us anything about position. It's only telling us about the velocity of this object. So if we were to describe, let's think for a minute how this thing is moving. It starts from rest. I know that because the initial velocity is 0. It starts from rest, and then it moves in the negative direction, and it is speeding up. I understand this because I can see that the velocity is becoming more negative. It's going from a velocity of 0 to a velocity of -2 meters per second in the first 2 seconds. So it is speeding up in the negative direction for 2 seconds. Then it continues at a constant velocity of 2 meters per second in the negative direction from second 2 to second 4. Then from time 4 to time 7, it is the velocity is becoming less negative. It is moving from -2 meters per second to 0 meters per second. So from time 4 to time 7, the object has slowed down while it's moving in the negative direction. At time 7, it actually changes direction. All of a sudden, the velocity becomes positive. That means that it's moving in the positive direction. So it changed direction. Now it is speeding up in the positive direction from time 7 to time 10. And then when it reaches a velocity of 2 meters per second at time 10, it begins moving at a constant velocity for the next 2 seconds. Okay. In part B, it asks us to identify the time periods when the object is moving first in the negative direction. So to find something that's moving in the negative direction, velocity must be negative, less than 0. And so when I look for the information we have on this object, from time 0 to time 7, that's when the object is moving in the negative direction, because that's the range of time when velocity is negative. To find when the object is moving in the positive direction, I look for v is positive. The velocity is positive. And velocity is positive from time equals 7 to time equal 12 seconds. The object changes direction when the velocity passes through 0, and that happens at time 7 seconds. Okay, then it asks us to create an acceleration versus time graph. They haven't given us the axes, so I'm going to have to do that. So let's always label your axes, otherwise, the graph is kind of meaningless, but we're going to do acceleration versus time. We have 12 seconds worth of data. Okay, and before we can decide on the vertical scale, we need to calculate the accelerations, which we will get from the slope of the velocity versus time graph. So in the first 2 seconds, the slope there, I see that the velocity is changing by -2 meters per second, and it does that in 2 seconds. So our slope is -1 meters per second squared. From time 2 to time 4, the graph is horizontal, and so the slope must be 0 in those 2 seconds. Then I have a long linear section of the graph. From time 4 to time 10, the graph is a line. The slope is the same the whole way there. So the slope there which is the acceleration, let's see, it goes from -2 to +2. So 2 minus -2, the velocity increases by 4 meters per second, and it does that in 1, 2, 3, 4, 5, 6 seconds. So we've got 4/6, which is 2/3 or 0.67 meters per second squared. And then the last 2 seconds, it's horizontal again, and so we again have an acceleration of 0. So on my vertical scale, it looks like I need to go from -1 to +1, and I need to show thirds. So this is 1, and that's 1/3 and 2/3. And here's -1/3, -2/3, and -1. So for the first 2 seconds, we said the acceleration was -1. From time 2 to time 4, the velocity is constant, so there is no acceleration. From time 4 to time 10, the acceleration is 2/3. And then from time 12 to time 14, I'm sorry, from time, messed that up. Put too many seconds on my graph. Sorry about that. From time 4 to time 10, it's 2/3, and then from time 10 to time 12, the acceleration is 0 again. Okay, it says, what's the average acceleration? Well, acceleration is the change in the velocity divided by the amount of time that it took for the velocity to change. In physics, when we talk about a delta, a change in something, it's always the final minus the initial. And I can look on this graph and see that at time 12, the final velocity was 2, and at time 0, the initial velocity was 0 meters per second. And this change happened over 12 seconds. And so basically, our average acceleration is going to be 2/12 or 1/6 meters per second squared. In the last question, it says, what is the total displacement over the full 12 seconds? Well, we can't, this graph is not telling me anything about the position of the object, but since it's a velocity versus time graph, I can look at the area between this graph and the x-axis, and that should give me the displacement. So let's shade that. Let's see. So the x-axis is where the velocity equals 0. And so I want to shade the area between that x-axis and the velocity versus time graph. If you look at this area, I mean, it has a strange shape, but it's a combination of triangles and rectangles. And so the shaded area equals the displacement, and that's going to equal, so a triangle is half base times height, right? So half times -2 meters per second times 2 seconds, plus we've got -2 meters per second, 2 seconds, plus half of -2 meters per second for 3 seconds. And then we're moving to the areas that are above the x-axis. So we've got half of 2 meters per second times 3 seconds. And then 2 meters per second times 2 seconds. A number of the items in this list, I have both positives and negatives, and so I could just cancel those. You know, if I have -4 plus 4, that's 0. And here's another one where I have a -1 and a +1. So it ends up that the displacement of this object is 1/2 times -4, which is -2 meters. Okay, thank you.